Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing stat and math at University of Toronto. And today we'll be going over some commonly asked math questions at both the high school and college levels. If you need some homework help or tutoring, please check out the link in the description below. Okay, so now let's start our session. Alright, let me just zoom in a bit. Okay. So the first question is asking us what is the associative property in mathematics. Okay, so let's copy down the question. What is the associative property in math? Okay, so let's start from the definition and then I'll give you a couple examples for practice. So the associative properties state that a change in grouping of two terms. Okay, so let's write the keyword down. So it is a change in grouping of two terms. Okay, and performing and addition or multiplication doesn't affect the end result of the operation. Okay, so addition or multiplication does not affect the result. Okay, so let's start with the rule for addition. So rule for addition. Okay, so for say we have A plus B plus C. Okay, and where A, B, C are just any numbers. Okay, thus in order to apply the associative property, we can have A plus B bracket plus C is equal to A plus the sum of B plus C. Okay, so as you can see, our left hand side we're grouping A and B first and then plus C, and then our right hand side we're grouping B and C first and then plus A, which will give us exactly the same answer. Yeah. So that is what we mean by rule for addition. And give an example. Let's see, we have 2 plus 3 plus 5. This is equal to 2 plus the sum of 3 plus 5. Okay, so on our left hand side we have 5 times 5, and on our right hand side we have 2 plus 8. Sorry. So 5 plus 5 is equal to 10. 2 plus 8 is equal to 10 as well. Okay, and yeah, so sometimes let's say we have a question, let's say 56 plus 99 plus 1. Okay, so let's see, we have a question like this. If we follow the regular order, like we calculate from the left to the right, like 56 plus 99, it's kind of complicated. So what we can do is apply the associative property. We group 99 and 1 first, because 99 plus 1 is just equal to 100, which is way easier than calculating 56 plus 99, right? So we have 56 plus the sum of 99 plus 1, which is 100, which gives us 156. Yeah, so that's like some technique you can use when you do your own calculation. Yep, so that's all we have for rule for addition. Now let's talk about the rule for multiplication. Rule for multiplication. Okay, so similar to rule for addition, we have A. Instead of plus, we have multiply. So A times B bracket times C is equal to A times bracket B times C plus bracket. Okay, and still A, B, C are just any numbers. Okay, so let's do an example. Let's say 1 times 2 times 3. And if we group the first two first, that will give us 2 times 3, which is equal to 6. And same thing, if we group the later two, which are 2 times 3, that's going to be equal to 1 times 2 times 3 is just equal to 6. And 1 times 6 is just equal to 6. So we have 1 times 2 times 3 is equal to 1 times 2 times 3. Okay. Yep. Yeah, so that's, I think that's all we got for this question. Let's leave a comment. Answer is correct. Well done. I just need to charge my computer. Okay, let me zoom in a bit. Okay, so our second question is asking us how many ounces in 1.75 liters. Okay, so let's copy down the question. So how many ounces in 1.75 liters? Okay, so whenever we come across a question that asks us to convert something in one unit into another, we always need to think about our conversion factor first, okay? So conversion factor, which in our case, 1 liter is equal to 33.814 ounces. Okay. Okay, so by knowing that, we start with the given quantity, 1 liter, and then use a conversion factor that will cancel out the given liter, which is at our denominator, and then we leave behind the n ounces. Okay, so let's write it here. So 1.75 liter times 33.814 ounce over 1 liter, and that is from the conversion factor, this part. Because for this part, the reason why it is not changed the original value of 1.75 liter is because that in this particular fraction, the numerator and denominator are exactly the same thing, and the only difference between them will be their unit. So in order to cancel out the liter, we put the liter unit as a denominator so it can cancel out, and which will give us the n ounces. Okay, so just need to plug that into the calculator, which give us 1.7 times 3. which give us 59.1745 ounces. Okay. So I'll just write one more sentence for explanation. So we use the conversion factor that will cancel out the given letter, which is right here as a denominator, and then leave behind the annual ounces. Okay. Yep. So our answer will be 59.1745. Okay. Okay, so let's leave a comment. Solution is correct. There's some technical issues again, so just give me a couple seconds. I'm just reloading the page. Maybe just 30 more seconds. Okay. Yeah, it's all good now. All right, so next we have what is the value? What is the value for tangent 60 degrees? Okay, so first let's draw a right triangle with a 60 degrees interangles. Okay, so that's 60 degrees, so that's 30, that's 90. Okay, and let's call that ABC. Okay, so recall that if it is a right triangle with 30, 60, and 90 degrees of its interangles, it is a special triangle which follows a fixed ratio of its sides given by, let's use another color. So this, the hypotenuse will be 2x AC would be x, and AB would be root 3x. Okay, so AC and AB and BC is just equal to 1 and root 3 and 2. Okay, so in terms of tangent theta, this is always gonna be equal to opposite over adjacent. Okay, so in our case, theta will be equal to 60 degrees as given in the question. Oops. Okay, so, oops. There's some technical issues with my iPad again. Okay. Yeah, so for tangent 60, it is equal to root 3x over x, where x can be cancelled out, which give us root 3 for our answer. Okay. Or you can also do it by following the senior tutor's solution. So he or she is solving this by approaching the unit circle. And then, yeah, so recall the tangent A is equal to y over x, and A is the angle, so y is just the y coordinate of the point, x is the x coordinate of the point. So according to the unit circle, that will still give us a root 3 as our value for tangent 60s. Yeah, so either way works. Let's leave a comment. Okay, solution is correct. Good job. Okay, so our next question. It is asking us what is the simplest form of the square root of 35 over 36. Okay. So let's use another color. So we just need to simplify root square of 35 over 36. Okay, and this is going to be equal to root 35 over root 36. And as you can see, 36 is a perfect square, so we can write it as 6 times 6, which is 6 squared, and that is equal to root 35 over 6, and that will be our final answer. And just want to develop a little bit more about perfect square. So perfect squares. So first, let's write some perfect squares out. So we have start from 4, so 4 squared is equal to 16, and 5 squared is equal to 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared is 100, 11 squared 121, 12 squared 144, 13 squared 169, 14 squared 196, and 15 squared 225. Yeah, I'll just stop here. So whenever you come across numbers on the right hand side of the equal sign, they can always be taken out from the square root and be written as the numbers on the left hand side, but without the exponent. Okay, just recall that the square root of anything square just gonna be the number itself. Okay, yep, so I think that's all we got for this question. So solution is correct. And next we have what are double angle identities of trig function. Okay, so double angle identities of trig function. Okay, so first let's write down those properties. So sine 2 theta is just equal to sine 2 sine theta cosine theta. Okay, that's the first one. And the second one will be cosine 2 theta is just equal to cosine theta, cosine theta squared minus sine theta squared, which is also equal to 1 minus 2 times sine theta squared. And tangent to theta is just equal to 2 tangent theta 1 minus tangent theta squared. Okay. Yep. So we can always use these identities to evaluate uncommon angles by representing them as twice of a common angle, right? So common angles like 45, 30, 60s, 90, so angles like this that we already know. Yep, so those are the double angle identities in trig. So let's leave a comment. So good. Yeah, so yeah, I think that's all we have for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit your own questions, please visit the link in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew from